Welcome to Coach Eichner's Math. Today we'll be talking about interior angles of a polygon. But first, let's make sure that we've got a good definition for what a polygon is. A polygon is a closed figure formed by segments called sides that intersect with other sides at their endpoints. So this top box has suggestions or examples of segments that all meet at the endpoints, which make closed figures, otherwise known as polygons. So these are all suggestions or all examples of polygons. Down below, these are all not polygons because they do not use segments, or when they do use segments, they're not all segments. One more option that I have not put on there, the most common thing to see, is for someone to tell me that this would be a polygon. Unfortunately, it is not a polygon because it is not a closed figure. There is a gap in the middle. So, looking down below, polygons can be convex or concave. Okay, and the easy way that I remember this is that if they are concave, they are going to cave in on themselves, which means that two segments must work back towards the middle. So, as I'm looking at it, 3 out of 4 of my shapes here are convex. The only one that is concave is this third figure. Notice how this vertex has gone back towards the center of my shape, which makes it a concave piece. Everything else would be convex. Okay. So, looking down below, we talk about polygons, and on occasion you're going to want to know what to name a polygon. So I would pause the video at this time and go ahead and write it down. The different sides determine the name of our polygon. So right here are the ways that we will refer to polygons. Welcome back. Notice the insided polygon is the one I want to talk about next. We use insided because after a certain point, it's kind of silly for us to continue talking about vocabulary. If I have a 32-sided figure, I could go figure out what a 32-sided figure would be called using Latin or Greek, or I could just say 32 gone. And just like that, it's real easy for me to know that that is a 32-sided figure. So, moving on. We know that the sum of the measures of the interior angles of a convex polygon with insides is 180 times n minus 2. Okay, this already holds up. We've already done this for a triangle. If we plug the number 3 in here, 3 minus 2 is 1. We know that a triangle always has 180 degrees. So, find the sum of the interior angles of a decagon. Well, a decagon is a 10-sided figure. So we'd say 180, 10 minus 2, which in this case would be 180 times 8. If you do not have a calculator, please pause the video and go get yourself a calculator, as calculators will be important throughout this entire thing that we are talking about. As we're looking at it, we will say 180 times 8, which is 1,440. So, 1,440 degrees total in a decagon. Now we want to find the sum of the interior angles of a 20gon. Use the same formula, 180, 20 minus 2, or 180 times 18. So, 18 times 18 would give me, not 18 times 18, 18 times 180 would give me 3,240 degrees. So a regular polygon is a polygon that is both equilateral and equiangular. We already talked about triangles are always going to be both if they are one. My angles are congruent, my sides are congruent, and this allows us to talk about them in more specific ways. Knowing that they are regular, I know that angles have to be congruent. So I can now say the measure of the interior angles, each, not all, but each interior angle. We're going to use the formula 180 n minus 2 to say that's what all of them would be, and then I'm going to divide by the number of angles. So the measure of each interior angle of a regular dodecagon is a 12-sided figure, would be 180, 12 minus 2, divided by 12. Now, we start getting to this point, I would just suggest typing that straight into your calculator, being very careful about putting your parentheses as you are going through it. We should find that each angle is 150 degrees. Okay, looking down below, got a 20gon. We want to find each of the interior angles of this regular polygon, and so therefore we will say 180, 20 minus 2 divided by 20. Type that in your calculator. 180 times 18 divided by 20 gives you 162 degrees. If the measure of an interior angle of a regular polygon is 108, find the number of sides. Well, all we're going to do is work backwards here. Hopefully we recognize that there's still 180 degrees. We're still going to use the same formula, n minus 2 divided by n equals 108. First thing, to get rid of my division, I'm going to multiply both sides by n. And then I'm going to say 180 n minus 2 equals 108 n. I'm going to distribute that 180 across my parentheses. I'll go ahead and use a different color to help people see it. Say 180 n minus 2, or excuse me, not minus 2, minus 360 equals 108 n. So moving on to the next step, I'm going to put my n's together by subtracting 108 n from both sides. I'm going to add 360 to both sides. I would say 72 n equals 360 degrees divided by 72. And I would know that the number of sides (360) divided by 2. The number of sides, not 360 divided by 2, 360 divided by 72, number of sides should be 5, which would make my shape a pentagon. So the number of sides would be 5. It would be a pentagon. So, looking on, got another opportunity here. If the measure of an interior angle of a regular polygon is 150 degrees, find the number of sides in the polygon. Again, same idea as before. We're going to say 180 n minus 2 divided by n equals 150, and I'm going to give you just a minute. That should be the hard part. Go back to the previous problem on example 5 and see if you can work the algebra. It'll be the same steps with just slightly different numbers. So as you're coming back, 180 n minus 2 equals 150 n. I'm going to distribute, say 180 n minus 360 equals 150 n. I'm going to put my n's together. I'm going to subtract 150 n from both sides. And I'm going to immediately add 360 to both sides. I would say here that 30n equals 360 degrees. I'm going to divide both sides by 30, and I would say that n is 12. That would be my number of sides for my shape. So, looking at it in a realistic site, it's all about algebra once we have our equation set up. Just got to keep working through it. Looking down below, find the missing angle. So, finding the missing angle is easy as long as I know the sum of those angles. I know this is a 1, 2, 3, 4, 5, 6, a hexagon. So the sum of those angles would be 180, 6 minus 2. Or I'd say 180 times 4, which is 720 degrees. So 720 degrees would be the sum. So right now I'm going to take the sum and I'm going to say 130 plus 130 plus 90 plus 130 plus 120. So right now I know about 600 of my 720 degrees. So I'd say 600 plus x equals 720. Or in this case, after I subtract the 600 from both sides, I would say that x is 120 degrees. Again, I was able to do that because we know that this is a six-sided figure, so we have the sum of 720 degrees. Look at our next problem. Find the measure of each angle. Well, this one's a little bit different, but the very first step I got to figure out, we've got 8 sides, which makes it an octagon, so I would say the sum of my angles would be 180. 8 minus 2, which is 1080 degrees. And I would say I'm going to add the sum up, so I've got 1, 2, 3, 4, 5, 6, 7, 8 x's. 8x plus 40 equals 1080. Subtract 40 from both sides, I would say that 8x equals 1020. Divide by 8, and I would find that each angle would be 135 degrees for my ones that are x, and the ones that are x plus 20 would be 155 degrees. So right there would be the answer. If it's x, it's 135. If it's x plus 20, it's 155. So, thank you very much for watching Coach Eichner's Math. You have a great rest of your day.